So continuing on with your WorkWise Math at Work book, I'm on page 39 and we'll talk about pages 39 and 40 in this lesson. And we'll just kind of keep that page there. That should help us some. And let's change to blue ink. So when we are talking about parts of a whole, we use fractions is the first sentence of this. So a lot of people use the pie or a circle that is a pie cut into parts. So what we do is we take the whole pie and we figure out how many parts we divided it into. In this particular one, we divided it into 4 parts. If I'm only interested in one of those 4 parts, I am interested in 1/4 or 1/4 of the pie. If I'm interested in 3 parts, I have 3 out of the 4. So the bottom number represents how many parts we divided the whole thing into. It's always based on the whole thing. The top number is how many pieces we want out of the whole thing. And that's really all fractions are. If I wonder if I can draw a circle. Let's see. Oh, I can. All right, so let's say that we divide this into, and we're talking, every time we divide this whole, we're talking about it dividing into equal parts. Ooh, that's a bad line. I mean, I can't just have a circle and have that much and then this much and say that I have 1, 2, 3 parts. I do have 3 parts, but they're not the same size. So we can't do that. It has to be the same size. So again, we have a whole circle. It's divided into 6 parts. And all I'm interested in is how many of the parts I want. So if I want, let's say, well, 1, 2, 3, 4, 5, 6, 7, 8. What am I thinking? That's 8 parts. Okay, so 8 parts. And let's say I only want 3. 1, 2, 3. So I'm taking 3 out of the 8 total parts. So my fraction is 3/8, or 3 of the 8 parts. So that's really all a fraction is. So let's get this junk out of the way and look a little bit more at this page here. So operations with fractions. Operation, that means addition, subtraction, multiplication, and division. Those are your 4 operations. So you can add and subtract fractions that have the same denominator. If you remember right, if you have the same denominator, bottom number, you can add these 2 fractions together. So you don't do anything with the bottom, you just add the top numbers. So 1 plus 1 is 2, and the 3 just kind of travels along with the numerator. Numerator is the top number, denominator is the bottom. Same with subtraction. The bottom number has to be the same in order for you to subtract, just like addition. Then you just subtract the top numbers, and the 7 tags along, so 2/7. All right? So if we are subtracting or adding fractions that have different denominators, like this one here, in order for us to add or subtract them, we have to make the denominators the same. So we look at what is the number that both the 2 and the 3 go evenly into. Well, 2 goes into 2, but 3 doesn't. 3 goes into 3, but 2 doesn't. So we have to find another number that's bigger than the 2 and the 3 that both of those go into. 4, nope, 2 goes into 4, but 3 doesn't. 5, nope, neither one of them. 6, 2 goes into it, 3 goes into it. So we're going to use the number 6 then as what we call our common denominator. So how did we get this 2 to be a 6? We multiplied it by 3. So if we multiplied the bottom by 3 to get it to be a 6, we have to multiply the 1 by 3. Same on the other one. We multiplied 3 times 2 to get this 6. So we have to multiply 1 times 2. Okay, so now I can I can combine these two. I can subtract because the denominators are now the same. So 3 minus 2 is 1, and again, you drag the 6 along with you. Now, the nice thing about multiplication and division is we don't have to find those common denominators. We don't care what the denominators are. So, for instance, to multiply, like here, we multiply the top numbers, we multiply the bottom numbers, and we get an answer. Now, sometimes that answer has to be reduced, but that's all we do. It makes life so much easier. Sometimes we use a whole number with a fraction. So if you are, let's say, measuring something with a tape measure, and it's 2.5 inches long, that is a whole number with a fraction, and that's called a mixed number. We're mixing whole numbers with fractions. Okay? Sometimes you're going to get numbers where the top number is bigger than the bottom number, and that's called an improper fraction. So we've got our fractions, we have our mixed numbers, and we have our improper fractions. So be able to know the difference between all of those, because I will be just throwing those out there, assuming that you remember what we talked about with those. Okay, so when adding and subtracting mixed numbers, let me see. Add or subtract the whole numbers, then add or subtract the fractions. So if I've got 5 2/3, and I'm going to subtract 4 1/3. The nice thing about it is the denominators are the same, so it makes life so much easier. If those were different, you'd have to make them common, like we did on one earlier one. So what the rule is, the book says, is subtract the whole numbers. 5 minus 4, and that's 1. And then we subtract these. 2/3 minus 1/3 equals 1/3. And there's our answer. So, not too terribly bad. So a few minutes ago, I explained to you what an improper fraction is. And that's what it talks about here, in which the numerator, the top number, is larger than the denominator. Now you can change a mixed number into an improper fraction and an improper fraction into a mixed number. So if you remember what I just said, an improper fraction is the one with the number on top bigger than the number on bottom. A mixed number is one where we have a whole number and a fraction, 12 2/7. Now we can go back and forth. We can go from an improper fraction to a mixed number pretty easily, and we do that by dividing. 12 divided by 7. Remember, the top number is first. You write it down, you write the division sign, and then you put the 7 in the only other place. So 7 goes into 12 one time. 1 times 7 is 7. And we have 5 left over. So that would be 1 and 5 over, remember the remainder goes on top and this number goes on bottom. Okay? So 1 and 5/7 is the same as 12 over 7. Now if we're given a mixed number like we are here, the way we change it to an improper fraction is we multiply the whole number times the bottom and add the 5. 1 times 7 is 7 plus 5 is 12. So that's where we get the top number, 1 times 7 plus 5. And it will always go over whatever the bottom number is. So the bottom number will always stay the same. Okay, so let's try another one real quick. 3 1/8. Change that to a mixed number. We take 3 times 8 and add 1. So 3 times 8 is 24, plus 1 is 25, and that goes over, always goes over the bottom number there. Okay, so that's changing back and forth from a mixed number to an improper fraction. All right, so now what we're going to do is we're going to work with fractions. So we are right here. Often you are in situations where you need to find a fractional amount of something. So, whatever this guy's name is, or lady, I don't know. Ikiro works in a bakery. Okay, so it's a boy or a man. His boss left him this note. Ikiro, Mrs. Carter wants 2/3 of her order to be chocolate cupcakes. She ordered 2.5 dozen. Why didn't she just tell him how many stinking cupcakes 2/3 is? Okay, so what we're looking at is we're trying to find 2/3 of 2.5 dozen. If you remember right, the of always means multiply. So 2/3 of 2.5. So that's what we're going to do here. 2/3 of 2.5. So that's going to look like this. 2/3 of 2 and 1/2 dozen. So first of all, we can't multiply a fraction times a mixed number. We've got to change this to an improper fraction. Okay, so that's why we did converting to improper fractions up there. So this is 2.5. To change that to an improper fraction, 2 times 2 is 4, add 1 is 5, and put it over 2. So that's going to be 2/3 times 5 over 2. Okay, so let's multiply 2/3 times 5 halves. Top numbers multiply, bottom numbers multiply. So we end up with 10 over 6. Another way of doing this is the way that I would probably choose rather than the way the book did. I would take 2/3 times, how many cupcakes is 2.5 dozen? Well, I know that 2 dozen, I know that 1 dozen is 12. So 2 dozen is 24. And 1/2 dozen would be 6. So she's ordering 30 cupcakes. So 2/3 times 30 is really what I'm doing. So rather than multiplying it by 2.5, I could multiply it with how many cupcakes 2.5 dozen is. So that gives me, I make this into a fraction. Whenever you want to make a whole number into a fraction, just put it over 1. So now I multiply 2 times 30 and 3 times 1, 60 over 3. That's an improper fraction. Let's change it to a mixed number so we can figure out how many cupcakes 60 over 30 is. 60 divided by 3. 20 cupcakes are going to be chocolate. So that's the way you do that one. So the next video will be going over the exercises that are going to go along with this. So this video just went over pages 39 and 40, and the next one will go over the exercises.